is built with enormous amounts of data. Up until recently, we've relied on data captured from the real world and painstakingly labeled it by hand. The next era of AI requires a scale, diversity, and accuracy of data that's impractical and in many cases impossible to capture through traditional means. The only way to produce the data we need is by synthesizing it. Like humans and all creatures, AIs learn continuously from their environment. Babies learn how to perceive depth and identify objects by experiencing their environment. They learn the rules of the world, physics, through experimentation. AIs learn in precisely the same way. They experience the world through the images, sound, and information we feed them. They learn physics through continuous experimentation, trial and error. But unlike us, AIs are born and raised inside a computer. The most natural place for them to learn and experiment is not in the real world, it's in a virtual world. In virtual worlds, AIs can learn in super real time, where 1 second of our time can be days' worth of life experience. In the virtual world, they are free to experiment, learning how to operate heavy machinery and drive multi-ton vehicles without risk of physical harm. Once an AI has learned a skill well in the virtual world, we can move its brain to a robot where it can operate in the real world. For this brain transfer to work, the virtual world must be indistinguishable from the real world. It must look, sound, and feel the same. The rules of physics must match the real world closely. Otherwise, the AI will have learned poorly. We have built Omniverse for this very purpose. Omniverse is our platform for building and simulating virtual worlds that are indistinguishable from the real world, leveraging the full might of NVIDIA's accelerated computing. 4 key technological advancements have recently converged, making the ideal conditions for the creation of Omniverse. First, with the introduction of NVIDIA RTX in our Turing generation of GPUs, we transformed real-time 3D rendering from a system that produces images that merely look good into a physically accurate simulation of how light interacts with matter. Previous techniques based on rasterization had hit a wall in terms of physical accuracy. But with ray tracing, we know we can simulate all aspects of the behavior of light. Virtual world simulation has always been limited to relatively small computers at the edge, mobile devices, gaming consoles, or gaming PCs. With recent advancements in data center GPU computing, we have the opportunity to leverage graphics supercomputers in the cloud, running simulations that are too large and compute intensive for traditional computers. Omniverse is designed as a cloud-native and scalable engine that can utilize the full capabilities of the data center. Pixar invented Universal Scene Description, or USD, and open sourced it in 2015. USD provides a common standard that allows us to describe virtual worlds with physically accurate pieces that can be composed into large virtual worlds. Omniverse is built with USD at its core, enabling easy and lossless interchange of 3D data between the rapidly increasing set of tools and simulators that support it. USD is to Omniverse what HTML is to the 2D web. In addition to creating a large market for world simulation, AI is the key to building of virtual worlds. The construction of high fidelity, physically accurate, and large virtual worlds is currently limited to a small group of artists who have spent decades mastering the craft of 3D design in visual effects and video games. Every nook and cranny of the virtual worlds we enjoy in films and video games has been touched by an expert artist. For 3D worlds to be as ubiquitous as 2D web pages, we need everyone to participate in the creation of such worlds. Fortunately, AI has advanced to the point where we can train them to help us build virtual worlds, augmenting average people with skills that would otherwise take decades to master. AI will make creating virtual worlds as easy as creating web pages today. All things that are designed and built by humans are typically first built in a virtual world. Bicycles, cars, bridges, factories are all designed with various CAD tools, well before they are built in the real world. Physically accurate and extremely fast simulation is key to designing the best and most efficient products. We can quickly test many iterations of a design in the virtual world at a fraction of the cost of what it would take to build them in the real world. Once the digital version of the product is complete, It's transformed into its real-world dual, one built from atoms instead of electrons. In most cases today, that's the end of the road for the digital version. But if we link the two manifestations, digital and real, they can evolve with each other. We can capture data from the real world through IoT sensors and devices and feed it into the digital model, keeping the twins in sync. Applying accurate physical simulation to the digital twin gives us incredible superpowers. We can teleport to any part of the digital twin, just like we can in a video game, and inspect any aspect of it reflected from the real world. We can also run simulations to predict the near future or test many possible futures for us to pick the most optimal one. We've built the Omniverse platform to unlock the full potential of digital twins, from design and creation to physically accurate simulation on our supercomputers. And now I'd like to welcome my good friend and colleague, Richard Karras, to tell us about the growth of the Omniverse ecosystem.
Thank you, Rev. We are supercharging a huge ecosystem. Starting with developers, worldwide there are over 25 million developers, and we see great opportunities to expand our Omniverse developer platform to encompass developers across all verticals that NVIDIA serves and beyond. NVIDIA currently has over 3 million developers in our program, growing from 2.5 million from just over a year ago. Omniverse is a robust and modern SDK, and with the recent release of Omniverse Code, there are now opportunities for hobbyists to professionals to create extensions, connections, and even full-blown applications on the platform. And with artists and designers, there are close to 45 million creators in the world, and that number is growing faster than ever. With the onset of growing demand for the content and world creations as we move into the next generation of the World Wide Web, commonly referred to as the metaverse. Now, a large percentage of these artists and designers are already familiar with NVIDIA and are using partner applications that have been NVIDIA GPU accelerated. Omniverse is a platform that extends and enhances existing workflows, meaning we don't replace partner applications. We bring new features and capabilities to them, like true-to-reality simulation and real-time photorealistic rendering, essential features in the growing need for content for virtual worlds and digital twins. And with enterprise, there are over 150,000 warehouses and over 10 million factories in the world today, many of whom are moving to automation and digital twins. As a matter of fact, the global digital twin market is forecast to grow over 40% in the next 5 years. Omniverse is designed from the ground up as a platform for the enterprises who serve these industries, as you saw some amazing examples of in the keynote earlier today. From developers to artists and designers, we are supercharging the ecosystem of Omniverse. We have some great examples of early indicators of success. For individuals downloading and making Omniverse part of their workflow, we have had a growth of over 10 times where they were just a year ago. Many of the leading 3D software applications across media and entertainment, architecture, engineering, construction, and operations, manufacturing, and industrial design are connected to Omniverse, with more coming every month. Plus, we're seeing a growing number of startup companies interested in using Omniverse as part of the platform for their work. There are many other ways to connect to Omniverse as well, not just software applications. Things like sensors, cameras, LiDAR scanners, many of which are essential for digital twins. And we're seeing great growth with connections here as well, over 10 times where we were a year ago, with hundreds more on the horizon for the year ahead. And lastly, Omniverse as a compute engine is something that can be licensed to power the next generation of software products for our NVIDIA partners. You saw the first one earlier today with the launch of Lumen RT by Bentley Systems. Bentley is a leading provider of software and services to design, build, and operate the world's infrastructure. And they licensed Omniverse to power their next generation of iTwin applications. We are in active negotiation with other leading software companies looking to use the power of Omniverse for their product lines as well. These are some great examples of how it's going with the Omniverse ecosystem. Now, with Omniverse Enterprise, we are empowering a global network of Omniverse Enterprise as a platform for them to sell and expand their product lines. We currently have over 65 partners worldwide, and 30 of them have Omniverse demo labs being set up all over the globe for our enterprise customers. This is building on our existing strong ProViz foundation, which has been serving the artist and designer markets for many years with NVIDIA. Omniverse is supercharging their already active networks. And we're seeing momentum with the leading companies making Omniverse as part of their workflow, such as BMW, Siemens, Ericsson, and those we featured today in the keynote, PepsiCo and Amazon. And we have over 700 more companies in our pipeline. Omniverse can serve all these opportunities from individuals to the world's largest enterprises because it's run on RTX systems, from laptops to servers, and even directly from the cloud, as you saw announced today. So Omniverse is for consumers, professionals, developers, and researchers across all industries. Omniverse Enterprise Software is a $150 billion market opportunity. And we estimate the available market opportunity for Omniverse software at this $150 billion because it's based on two main use cases immediately in front of us. First, we estimate that there are 45 million designers, those designers that are creating in industries such as media and entertainment, architecture, engineering and construction, manufacturing, and industrial design. Many of these are end-user customers for our ProViz products already, and Omniverse Enterprise can help them modernize their existing workflows. And second, we have Omniverse opportunities for our digital twins with Omniverse. This will serve millions of factories, warehouses, and fulfillment centers across the globe. And we already have active engagements with hundreds of them in these early days of Omniverse Enterprise. We're investing in our Omniverse ecosystem, we're empowering our ProViz partner network, and we're building a long-term subscription-based model that will provide even more opportunities in the future. Omniverse software and chips and systems equals a $300 billion market opportunity, and we're going to go get it. Thank you very much. Next up is Jeff Fisher to talk